Hey there, science enthusiasts! Welcome to another exciting journey into the world of chemistry. Have you ever wondered how those amazing color-changing materials work? You know, the ones that seem to shift hues like magic right before your eyes? Today we're going to unravel the mystery behind these fascinating substances and explore the science that makes them possible. So, let's dive into the chemistry behind these color-changing wonders. First up, we have thermochromic materials. Thermochromic materials are quite popular and for a good reason. They change color with temperature. Imagine a mood ring. At its core, a mood ring contains either liquid crystals or leucodyes. These components are the key to its color-changing magic. Liquid crystals twist and turn with temperature shifts, altering the way they reflect light and, consequently, their color. It's like a dance of molecules responding to the heat. Leucodyes, on the other hand, undergo a chemical reaction when heated or cooled. This reaction changes their molecular structure and voila, their color. Next up we have photochromic materials. These materials change color in response to light, particularly UV light. Ever seen those cool sunglasses that darken in the sun? That's photochromism in action. These materials contain molecules that absorb UV light and rearrange their structure. This structural shift makes them absorb more visible light, creating a darker hue. And guess what? When the UV light is gone, they revert to their original form. It's like having sunglasses that automatically adjust to the brightness of the sun, providing optimal protection for your eyes. And let's not forget electrochromic materials. These materials change color when an electric current is applied. Think of smart windows that tint to control sunlight. The electric current causes ions to move within the material, altering its color. It's like flipping a switch for instant shade, making these materials incredibly useful for energy-efficient buildings. Now here's the cool part. These materials aren't just for fun gadgets, they have practical applications too. For instance, thermochromic pigments are used in baby bottles to ensure the milk is at a safe temperature. Photochromic lenses protect our eyes from harmful UV rays. And electrochromic materials help us save energy by controlling indoor lighting and temperature. So what's the takeaway? The next time you see a color-changing material, you'll know it's not magic. It's science at its finest. The remarkable interplay of molecules, light, and temperature creates these mesmerizing effects. Thanks for tuning in, and if you enjoyed this dive into the chemistry of color-changing materials, give this video a thumbs up and subscribe for more science wonders. Catch you in the next one.